Hey, welcome to another video. And this is a topic which is very near and dear to my heart, and this is called first principles thinking. First principles thinking is not just important for your studies, but in life. If you're becoming an entrepreneur, if you're going into startups, if you're going into business, first principles thinking is worshipped in Silicon Valley. Now, let me just tell you how I understand first principle thinking. Elon Musk talks about it, Naval Ravikant talks about it, and it's a really, really beautiful concept. So, as science students, if you're a commerce student and watching this video, this still applies to you. Again, always actions. So, what science students do, what scientists do is that they perform an experiment and they keep in mind which are the constants, which are the variables. Now, they have a clear outcome of what they want to achieve with that experiments. They have a list of what resources they're using and what variables they're tracking. Then they see what were those variables before the experiment and what were those after the experiment. If you have done any sort of practicals in class 11th and 12th, you would understand what I'm talking about. Now, what is important here is that what makes science scientific is that the understanding the relationship between the variables and how those variables and the relationship between them affect the outcome. Okay, that is one thing, and that forms the whole basics of any science, basically, specifically physics. Now, you also need to understand which variables are unknown. For example, not unknown, but you can't control. For example, the temperature of the area, the humidity, the pressure. If you're not able to control, you also need to take those into account. To illustrate with the help of an example, let me think of a quick experiment. Let's say titration. For non-science people, I'm just explaining how titration works. You take an acid, you take a base, you take an acid. Where do you take it? Yeah, you take an acid in a beaker, you take a base in the burette. Burette is a really long tube, and you just keep it dripping down. You add an indicator, you keep it dripping down until the indicator changes the color. Why? What matters here is the volume. Which variables do we have in control? We have in control the normality, the amount of acid we have taken. In simple words, we'll use an amount instead of normality and molarity, not getting into the technical terms. Understanding the concept is more important. Now, next we have the burette. In burette, we care about how much volume are we taking, like we're lowering or increasing. So those are the two variables that we can control right now. What also affects is the amount of indicator that you have added, is the temperature of the area, what kind of water are you using, and there are many different variables, but we neglect the effect of those minor variables because those don't influence the outcome that much as compared to the normality of the acid and the volume of the burette. Now, just giving you an overall idea of how first principles thinking works. First, in simple words, first principles is this: break it down and build it back up. You take you take a system which has many different variables, you break it down into its most fundamental pieces, and then you understand how each piece is contributing to the outcome and how each piece connects to the other piece and how they together contribute to the outcome. And then you analyze how the changes in one variable is reflecting in the outcome. So you break it down and then you build it back up, and then you do this again for all the variables one by one, and then you can have a complete concrete idea of how each variable is changing the outcome. So now you can control the outcome. Now, first step to inculcating, I'll honestly tell you how this applies into your studying by giving you an example. Okay, so just understand the concept, just try to internalize it and understand it. So we take a system and we first figure out what are the variables in there. For example, in this particular example which I gave of the titration, it's that the variables are the normality of the acid and the volume of the base. What does each variable do? Now, what is exactly the use of each variable? For example, acid adds H plus ions, base adds OH minus ions. So how exactly is it contributing towards the process that we're doing? Now, what is the relationship between the variables? Now these places, acid and base, they're contradicting each other, they're opposing each other. Very simple concept, just a two variable thing. Now what is the relationship between the two variables and how does the outcome change? If you increase the, like, I honestly don't remember the titrations that well, so please don't come after me for that. So, but if you increase the normality, I think the titration point shifts. So like where exactly you're getting the titration, that will shift. If you increase the amount of acid, you would have to increase the amount of volume of the base also, but the normality remains the same. So yeah, this is how it changes. Yeah, I know some chemistry nerds are coming after me after this video, but I'm just trying to prove my point here. That being said, now let me show you an example of how exactly we will use first principles thinking in a particular example which could be asked in our exams. So we're back with the example. Now looking at this, all the non-CS people will get intimidated. Bro, what is this? It's too complicated. Don't worry, chill. I'm going to explain this to you in the simplest form possible. Wait a minute. Just keep my laptop right here. So what this program is, it's about matrix multiplication. In class 10th, you would have studied. A matrix is what is like this, and it is a collection of elements, numbers, and you multiply them. And there's a specific method that we follow to multiply these matrices. So let me just multiply it right here in front of you, and then explain each step as I'm doing it, and then I'll explain this program, and then I will tie how first principles thinking is being used to do this process. I use this program, it's because most of the people can understand it. I could have used many difficult programs, but it's no point. Now, coming to matrix multiplication. Just a minute, let me adjust my mic. Yes, sir. Now, we have this matrix right here, and it's a 3 cross 2. This one is 3 cross 2, this one is 2 cross 2. First thing we need to understand is that these two numbers, the columns of the first matrix should be similar to the rows of the second matrix, which is correct, which is true right here. And then we just start multiplying. You multiply rows with, let me just tell you, so we'll multiply 1 with 7. The resulting matrix will be a 3 cross 2, which means 3 rows and 2 columns. Yes, 3 rows and 2 columns. So 1 into 7, 8. First row, first column. Wait. This is such an aura minus moment. We are back. I just forgot how to multiply matrices, but anyway. So yeah, we'll multiply these rows with these columns. So for 1 into 7 plus 2 into 9. I'm just doing this so that you guys can recall how matrix multiplication is done, so that I can explain this program. 2 into 9, and then here we have what do we have here? First row with this column, yeah, for 1 into 7, 2 into 9, and then on this one we have 1 into 8 plus 2 into 0. Here we have 3 into 7 plus 4 into 9. Then we have 3 into 8. Please pay attention here, it's going to be important. 3 into 8 plus 4 into 0. 5 into 7. And then 6 into 9. Everyone's favorite numbers. 5 into 8. Plus, 5 into 8 and 6 into 0. Now we'll add them. 7 plus 18. 21 plus 36. I'm not sure if you're able to see. Looks like you should be able to see. But if you're not able to see, just understand this, okay? And probably do it on your own. You guys are math students. Most of you are those of you who are math students, you'll understand. This is a very simple concept. 36, 35 here. 6 times 54. Then 8. So I'm sorry for the interruption. My phone storage got finished. But record a video course, they said. It'll be fun, they said. I'm sorry, I'll be back. So this is here, we have done the matrix multiplication right here. Now we come to the programming part. So for those of you who are non-CS, I'm explaining in simple words. For those of you who are CS, you already know this. So just bear with me. Now we have M1, M2 and result. These are the three matrices. M1 is the first matrix, we can take this one. M2 is the second matrix, we can take that one. Wait, let me come here. Yeah, we can take that one. Okay, now result is the final matrix, which is this one. Okay, R1 C1 rows and columns of the first matrix, R2 C2 rows and columns of the second matrix. So let me just put the numbers here. First one has 3 rows, 2 columns, the other one has 2 rows and 2 columns, and this one would have also 3 rows and 2 columns. Okay, now we have a loop. What is a loop? A loop is a set of statements which executes multiple times. Okay, now we have 3 loops inside one another. Now here the things become fun. Now first, what the first loop will do is that it is going till R1. R1 is the number of rows of the first matrix, and second row is the second loop inside it is going to the it's going to the number of columns of the second matrix. What I am doing here while explaining to you guys, isolated the variables. Okay, now I'm telling you what each variable does. Then we'll find the relationship between variables, and then we'll find how the outcome is affected. 4 steps for first principles thinking. I isolate each variables. We need to know what each variable does, how the relationship is there between the variables, and how the outcome is affected. Coming back, here we have again. So we need to understand here is that the first loop is going through the rows of the first matrix. Okay, when I equals to 0, I think so, I'm right. Yeah, when I equals to 0, when I equals to 1, I equals to, yeah. So when I equals to 0, it will be here, then it will be here, then it will be here. It will point to this one. Okay, next, second row, the second loop, what it is doing, it's going into the columns of this matrix. Okay, right here. Okay, when I equals to 0, it will go into this one. I equals to 1, it will point to this one. Okay, makes sense? Next, yeah, where was I? Now comes the interesting part. As these loops update, we need to take care of the result. We need to make sure that we add these here. Okay, we should add these here. However, also while we have added these, and we also need to make sure that this sum does not add to the sum of the elements which is supposed to go here. Okay, so that is why we are making result I, j equals to 0. For example, let's say I and j both are 0, 0, 0. First row, int I equals to 0 less than R1. ठीक है, correct? J equals 0 less than R1. So we have 1 and 7. Not yet. So this is the first row. We are taking both of these here. Okay, we are not sure which one we are using yet. Okay, because this is in the third loop. So we are taking this row, we are considering this row first and second, then we are doing 7 and 9. Please understand that the reason I am explaining this is to illustrate the point of first principles thinking. How I am explaining it, how I am boiling it down to simple words, how I am pointing out specifically what each variable is doing. All of this is a part of first principles thinking. It is very, very important for you to develop first principles thinking if you are going into a technical subject, and even for non-technical subjects. Now, mostly for technical subjects, by the way. So yeah, we came back. We will say that the result of this one 0, 0. Please understand if you don't know how the matrix are numbered. So this is 0, 0, 0, 1, 1, 0, 1, 1, 2, 0, 2, 1. Am I right or am I right? Yeah. Okay, cool. Numbering starts from 0, goes until the number of rows or number of columns minus 1. Cool. So result ij equals to 0, which means we have initialized this equals to 0. Now initialize means giving the value. Now for, yeah, here we have the third loop. K equals to 0, k is less than c1, k plus plus. Now comes the interesting part. Why are we doing k here? K here, as I said, this considers the whole first row. Now C1 is the number of columns in the first row, in the first matrix. So in order to consider each of these one by one, we have this C1 variable. We have this K loop which is going into the C1 variables. First, principles thinking, understand what each variable is doing, what is the relationship of this variable with other variables. Now, it makes sure that we go into each of the variables, sorry, each of the elements of any particular row. Now, next, result ij plus equals to mik into m1ik into m2kj. Most important statement of this entire program, the last one. First, let me tell you, this is the multiplication symbol. What we have done right here, 1 into 7, 2 into 9. This is the multiplying part. Now, plus equals to means, if I say r plus equals to 1, let's say r equals to 0, and I say r plus equals to 1, then r will become 1. And then I again do r plus equals to 1, then r will become 2. So 1, so here is r plus equals to 1 equals to, that means r is equal to r plus 1. So since it has already the value of 1, then we add another 1 to this, then it becomes 2. So r plus equals to 1 means r equals to r plus 1. We just what is existing there, and then we add stuff on top of it. We do not remove the previous things. Coming back, let's remove this one. Why we need to do this? Again, why? What is the relationship? Why does it contribute? How does the outcome change? What is the relationship between other, what does each variable do? We need to understand each thing. This is how exactly I would approach if I were studying this program. Although that is not how I did, I just memorized it. So I would not recommend it. But if you want to understand in depth, then you need to understand this way. Because that's what happens. That if you see people, you would have, of course, looked at your friends or peers or people whom you've studied and whom you studied with and admired how they just study anything once and then they go for the exam 3 months later, 2 months later, and still they have everything in their mind. The reason being that when they study and understand any topic, they do it, they go in depth, they understand what exactly is happening, and then the cogwheels of their brains turn and they get it. They just get it, and so they know what is happening. Now they can study 3 months later and then everything will come back to them because they know how the things are happening. I hope I'm making sense. Next. Yeah. So the reason we are doing plus equals to here, as I said, r equals to r plus 1, which means we'll add on top of it, is because we have this thing. Let's say we have this 7, and on top of that 7, we need to add this 18. Okay, that is what is happening. Results ij plus equals to m1 ik. Now let me explain what exactly is this one. Result ij, which means this one, the first row of first column, plus equals to, right now this is empty as we had done right here, plus equals to mik. K is 0, I is 0. Okay, m1 ik means this one, 0 0. m2 kj, right now everything is 0. So then we do kj 0 0, 1 into 7, 1 into 7. Okay, we added it. Now we go into the next iteration of this k loop. Now k becomes 1. When k becomes 1, everything else is still 0. Okay, when k becomes 1, we go, then k becomes 1, then we do results ij, still this one only, still this, of the resultant matrix, the first row, first column, then m1 ik, m1 0 1, which means first row, second element, 2. Okay, into m2 kj means second row, first column, 9, 2 into 9. Okay, now this loop is done. It became less than C1. If it becomes a number of like C1, which is 2, then we go, this statement ends. Now this increases, j. In software engineering terms, this is known as a dry run, where you simulate, you basically see what exactly is happening with each iteration of the loop so that you understand the relationship between the variables. Again, first principle thinking. Next, I'm not going to explain the whole thing, but I just want to illustrate the updation of each loops at least once. Next, j equals to 1. J equals to 1. Now we need to take in mind that result ij, which means 0 1. Result ij means 0 1, which means first row, second column. Here, now we initialize this equals to 0. Okay, like this container becomes 0 because this is done now. Now we move to this one. Then we go for int k equals to 0. K is again 0. K is less than C1 columns and K++ as I told earlier. Result ij. Here, now j has become 1. Ki equals to 0. K equals to 0 right now. Result ij, which means result 0, 1. 0, 1 matlab this one, and equals to this plus equals to, which means is 0 plus m1 ik. Ik means again 0, 0. m1 ik, wait, m1 ik 0, 0. When we multiply using this, so we'll multiply again 1 into 8 plus 2 into 0, right? Ik is 0 and 0. 0, 0 again points down to this variable, the number 1. Now once we do that, we multiply it with kj. Kj is 0, 1. 0, 1 means first row, second element, 8. So 1 into 8, 1 into 8. Okay. Once this is done, then k becomes 1. Okay, k becomes 1. And then what happens? Result ij, again this one only. Okay, 0, 0. Then m1 ik. Ik means I is still 0, 0 and k is 1. 0, 1 matlab means 2. Okay, now we go to this one. 2k into j. Now both are 1, which means 1, 1. 1, 1 is second row, second column. 2 into 0. 2 into 0. Done. So now this one is also completed. We added 8 first, we added 2 into 0 first. Okay, so we do 2 into 0. Now this loop is done. Now j has become less than 2. When it becomes 2, the loop breaks. Now we update I. Now I becomes 1. Everything else becomes 0. Okay, I becomes 1, which means it points to this second row. I'll just give one example. Okay, this points to the second row, and then we go j equals to 0. I is 1 here, j is 0. C2, again this is, we have made this empty. Result ij equals 0, we have made this empty. Also another important concept, once you understand something, like now you know what is this line doing, which is result ij equals 0, just emptying it. Once you understand a topic, it's good. Now you understand how the internal mechanism is working, and then you understand what's the outcome of it. Do not waste time multiple times. Do not waste time trying to understand and grasp the whole internal mechanism multiple times. Okay, now you know how it works. Now just we have this, and this is how the outcome is changing. Do not need to understand the internal mechanism multiple times. Just going to be a waste of time because you've already understood it once. I know this, I'm saying this because I used to do it. I had really big self-doubt that, okay, I've understood this multiple times, but what if I forget? It's fine. You understood it multiple times. If you forget, you can go back to it again. Okay, very good. Now coming back to the second row. Second row, we have this here. Second, 3 and 4 over here. And now j is 0. J is 0 means still this one. J is 0, j is less than C2. Next we go to result ij is 0, which means that we have made this one 21 and what is this 36. Yeah, so we have made this empty. Now k equals 0. Right now, as I said, I1, j0, k0. Result ij. Ij means second row ka first column. Second row we have this here, first column is this here. This one we are talking about. Next, I hope this is visible. Yeah, I1 and k. I and k. I is 1, k is 0. So second row, first column, this element, number 3, into k and j. Second row, sorry, first row, first element, this one, 3 into 7, 3 into 7. Similarly, we update this, k becomes 1, ij, still this one, 1, 0, which means this one, second row, sorry, yeah, second row, first column, plus, so we already have this 21 stored. Okay, 7 into 3. Then ik, m1 ik. I is again here 1 only. So first row, and k is 1 now. So first row, second row, second column. First is the index. Second row, second column. Now we go to this variable, which is 4. Now kj. Now k has become 1, j is still 0. So we should keep that in the back of the mind. I have this because I've done this program multiple times and I'm a software engineer. So yeah, kj. Second row, first column. Second row, first. What? Yeah, second row, first column. Yeah, correct. We done 3 into 7. We did 4 into 9. 36. That's how we do matrix multiplication, but I'm not teaching you matrix multiplication here. I'm teaching you first principles. So please observe this video, watch this again, probably in 2x speed. Observe how I'm teaching and explaining you. First of all, I started with isolating each of the variables. Then I told you what each variable does. Like this is a counter of each variable. Yeah, also ijk. Ijk is a counter. Counter is basically which keeps updating and it points to different places. Like for example, I is for here, j is for this one, k is for different places. So k also points to columns only. So we need to understand what each variable does. First of all, we isolate the variables, then we understand what each variable does. Then we understand the relationship of the variables with each other, like I, j here, c2 here, then kj, this whole chop suey right here. We understand the variables relationship with each other, and then we understand how the outcome, which in our case is the resultant matrix, how the outcome changes as the variables change. So ladies and gentlemen, this was first principles thinking for you. I know this is a really complex video. Please understand this. This is I'll get into more in depth. Not more in depth, but I'll explain you how this concept applies into understanding programs and understanding those subjects which you need to understand and not memorize. So thank you. I'll see you in the next video. Bye and have a nice day.